This video is about representing data graphically, and it's mainly about histograms. And the first thing that I want to do is just clear up what the difference is between bar charts and histograms. So first of all, bar charts can be used to represent categorical data of either type or numerical discrete data, but only discrete. On the other hand, histograms are used exclusively for numerical continuous data. So just take a moment again to recall the definition for numerical continuous data. It's measurable data. And the types of data that fall into this category would be things like time, height, weight, distance, area. Generally, if we're drawing a bar chart, we're drawing it from a frequency distribution table. But for histograms, we generally have a grouped frequency distribution table. So this is a table that has intervals, and there's an earlier video explaining about that type of frequency distribution table. Finally, there are some visual differences between bar charts and histograms. For bar charts, we may leave a space between our bars. We don't have to, we might run them together, but we're allowed to leave a space. However, no space is left between the bars of a histogram. In a bar chart, each bar can be labelled individually on the horizontal axis. That is, we usually write the name of the bar directly below the bar, whereas with the histogram, the horizontal axis has a scale. So this is like a number line along the horizontal axis. So let's have a look now at an example of how we'd approach a histogram question, what the information that we're given looks like, and what we need to include in our diagram. So here's our example. This is a grouped frequency distribution table, and you can see the groups here are 0 to 2, 2 to 4, 4 to 6, and 6 to 8. Those groups can be called intervals or classes as well. On the second line of the table, this shows the number of students in each case. This can also be called the frequency. So 4, 3, 5, and 2. The table shows how long it took 14 students to solve a maths problem. Represent the data on a histogram. Now, first of all, let's just have a think about why it's a histogram specifically they're asking us to use. Remember what we said at the start of the video. We use a histogram to represent what kind of data? We use histograms to represent continuous numerical data. Continuous data is data you can measure, and the time was measured in each case here. You might wonder when you're looking at your table how 2 can be in both of these intervals. Just for clarity again, this interval 0 to 2 means that we go from 0, we include 0, and we go all the way right up as close as we can get to 2 without including 2. So we can think of this as being from 0 up to 2, but values that are less than 2. This interval includes the value 2 and every value right up as far as 4. So if somebody took 3 minutes and 59.999999 seconds, they'd be in this interval. We don't include the 4 itself. 4 is included in this interval, and so on. So now let's get down to the business of actually drawing the histogram. The first thing that I'm going to note here, just to the right of my squared paper, is the little acronym SALT. And this is just to help me remember to include certain things in my graph. And those things are scales, axes, labels, and title. And I'll explain each of these as I come to them in the diagram. So the first thing that I do is I draw my axes. My axes are just my horizontal and vertical lines around the outside of my graph. The next thing that I must do is put the scales on my axes. This is just like the number lines that run along those axes. The top line of the table will always go on the bottom line of the graph. I'm going to start with 0. And then since my intervals are going up in 2s, I'll go up in 2s as well. Notice that every time I put a number in, I put a dash to indicate the location of that number. You need to have the dash and you need to have the number. They're my scales on the horizontal axis. Now I need to also put in my scale on the vertical axis. My biggest number here is 5, so 5 is the furthest up that I'll have to go. And again, for each number that I put in a dash. It's really important to have both of those things. Okay, I also want to label my axes. So my horizontal axis represents time, and I actually have units for time in this question. I can see up in the table that the time is in minutes. So I should mention that also. On the vertical axis, I'm showing the number of students, so I fill that in there. I also need to have a title for my graph, and this should make reference to what's happening with the data. So here it was how long it took students to solve a maths problem. So I'm going to call this the time taken to solve problem. Okay, now that I've ticked off everything there from my little checklist, I can actually put in the bars of my histogram. My first bar goes from 0 to 2 and up as far as 4. This is really the easiest part of the question. The next bar goes from 2 to 4 and up as far as 3. The next bar runs from 4 to 6 and up as far as 5. And my final bar goes from 6 to 8 up as far as 2. I might also be asked some questions about perhaps my table or my graph. I might be asked, what is the modal class? We encountered this back in the video on grouped frequency distribution tables. You can see the solution by looking at the frequency, picking out the highest frequency, and your answer then is the group relating to that. So the modal class is 4 to 6 minutes, and you can also see that the 4 to 6 minute class is the tallest bar in the diagram. We might also be asked questions like how many students took under 6 minutes. Really, I'm looking at my table to answer this question. 6 minutes is here. This group took less than 6 minutes. So did this group, and so did this group. So I should add the frequencies together to get the answer. 4 plus 3 plus 5 gives an answer of 12 students. And finally, we might see a question like this. What is the maximum possible number of students who took over 5 minutes? Again, really, we're referring back to our grouped frequency distribution table here. So who could have taken more than 5 minutes? Well, this group at the end definitely took more than 5 minutes because we know that they all took between 6 and 8 minutes to complete the puzzle. These students here took between 4 and 6 minutes. I don't know exactly how long each individual took. It's possible they all took 4 minutes, or maybe they all took 6 minutes. But it's definitely possible that they all took more than 5 minutes. And I'm looking for the maximum number of students that might have taken more than 5 minutes. So I'm going to say, well, they could have all taken more than 5 minutes, so it's possible that they are in that category. So my answer for question 3 is to add 5 and 2 to get 7 students. Notice that with this question, we were initially asked to draw the histogram, and the arising questions that went with it generally meant that we had to go back and look at our grouped frequency table again. You might also be asked questions like find the mean of the grouped frequency distribution. To remind yourself how that works, go back and watch the video on how to find the mean from a grouped frequency distribution again. If you want to test yourself on whether or not you know that well, pause the video now, calculate the mean, and I'll put the answer for that calculation at the end of the video.